Alright guys, I'm going to do letter I in tonight's video. So this is a quadratic formula question, even though it's a word problem. So we're going to read through it and I'm going to explain how the quadratic formula is going to apply here. So a cliff diver on a Caribbean island is jumping from a height of 105 feet. So before I even move forward, I can assume right now that 105 feet might be useful to us. So I'm actually just going to draw a picture to start of what we're dealing with. We've got a cliff diver. He's on a cliff above the water. And he is 105 feet in the air. So from here to here, that's 105. And he's going to jump off of this cliff and into the water, but it says he has an initial upward velocity of 5 feet per second. So that means when he jumps, he's not just stepping off the cliff, he's jumping up. So he's going to come up like this and then come down into the water. He's going to hit the water. So you notice here that what we have is actually just a portion of a parabola, right? And that would be the other part of the parabola there. This is a parabola, and the equation of that parabola is given right here. So the equation that models the height of the diver is called h of t. So that's this equation. And that's how high he is above the water in feet as time t passes. Okay, so this parabola right here is h of t. Normally, functions, we call them f of x or g of x. This is not a function of x, it's a function of t. T represents time, but it's just like any other function that we've used in the past, and this one is a parabola. So the question asks, how many seconds, and make sure that we give to the nearest hundredth, does it take the diver to fall 45 feet below his starting point? All right, so his height is going to be what? Because h of t represents height. So first of all, let's figure out how high up he'll be. Well, if he falls 45 feet, how high up is he? He starts at 105 feet. He falls 45 feet. So now he's at 60 feet. So we can say that the height of the diver, when he falls to this point, is 60. So I'll rewrite my function here just so you guys can see where I'm going with this. This function represents how long it takes the diver to get to a specific height. And we know now that his height is 60 feet. This is a quadratic. And remember that when we're dealing with a quadratic, we want it to equal 0. So let's move this 60 over to this side so that we have 0 equals negative 16t squared plus 5t plus, now it's 45. All right. Now you've got a quadratic. And we've got to figure out how long it's going to take the diver. So what will t be to fall 45 feet below the starting point? We've already accounted for his height. So now we're going to figure out what t equals. If I want to solve for t in this quadratic, I really only have two options. I could either use completing the square, or I could use the quadratic formula. So let me write out the quadratic formula, and then we'll plug in the values. All right, so x is equal to negative b. b is 5. Plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is just like using the quadratic formula as we've used it in the past. So we're just going to make sure that we solve this piece by piece. We've got negative 5 plus or minus the square root of 25 plus 2,880 over negative 32. I'm simplifying it one step at a time. That's going to be negative 5 plus or minus the square root of 2,905 divided by negative 32. So it would be at this point that we would use a calculator, and we would use our addition sign and then use our subtraction sign and see what kind of numbers we get. Remember that it says to round to the nearest hundredth. So after I use my calculator, I'm going to end up with two numbers. If I use an addition sign, I'll end up with negative 1.53 seconds. And if I use my subtraction sign, I'll end up with 1.84 seconds. And remember, he's diving into the water, so there really only is one answer, but we're getting two options here. So we have to decide which one of these makes sense. Well, what makes more sense? That it took him 1.84 seconds to hit the water, or that it took him negative 1.53 seconds to hit the water? That makes no sense, because it can't take him negative time to hit the water. That just doesn't make any sense in the real world. So it takes him 1.84 seconds to hit the water. We throw out the answer that makes no sense, and that's the answer. All right, hopefully that was helpful. The second one is similar to this, but I forgot to add the part that involves actually doing the quadratic formula. So we'll see what you guys can do with the question that's there. It should be pretty quick. Good luck on the rest of this, guys. We'll practice some more tomorrow for the quiz on Thursday, and I will see you tomorrow.